Section 2.6 is on exponential notation. We're going to do it over 2 days. Shouldn't be too bad today. I think most of this should actually be review for you, so that's good. Next day, oh boy, it's a doozy. Next day will be tough. So good luck today and even more luck next day. Okay, so we're going to learn all about these different rules with exponents. So the first two rules we're going to learn is what happens when the exponent's 1 and what happens when the exponent's 0. And I think you already know these, but just to make sure, in case you don't remember, over here I'm going to write something. So let's say, let's figure out what 2 to the 4th power is. What's it mean, first of all, 2 to the 4th power? It means 2 times 2 times 2 times 2, and 2 times 2 times 2 times 2 equals 16. Okay, let's keep going. 2 to the 3rd power is 2 times 2 times 2, which equals 8. 2 to the 2nd power is 2 times 2, which equals 4. So the next one, obviously, we're going 4, 3, 2. The next one down here would be 2 to the 1st power. Pretend you don't know what that equals, because I think you already do. How could you use this to figure it out? Well, you could look at this. You have 4 2's, then 3 2's, then 2 2's, so you must just have 1 2 here. That's one way you could think of it. Or the other way you could look at it is, what do you do to go from 16 to 8? Divide by 2. How about to go from 8 to 4? Divide by 2. So what do you do to go from 4 down to the next one? Divide by 2. 4 divided by 2 is 2. Great. We can use this same sort of pattern to get what 2 to the 0 power. Do you remember what anything to the 0 power is? Well, if you don't, let's figure it out. You would take this 2 and you do the same thing. Divide by 2, divide by 2, divide by 2, divide by 2. What's 2 divided by 2? 1. There you go. 2 to the 0 power is 1. Yes, I know many people think 2 to the 0 power is 0. It's not. Anything to the 0 power is 1. So let's write this down. The way we can write for an exponent of 1 is that a, where a is any number, a to the 1st power is equal to a, right? 2 to the 1st power is 2. 7 to the 1st power is 7. M to the 1st power is m. Not too bad, right? Okay, a to the 0 power. So any number to the 0 power, that's an a, not a 0. A to the 0 power equals 1. That's what we said here. 2 to the 0 power is 1. 12 to the 0 power is 1. All this stuff in here, whoa, look at how complicated that all this stuff is. But it's all raised to the 0 power, so it is 1. Okay, now, be very careful here. I'm going to even write careful over here. This first question here, out of these two here, the first one has -8, all in brackets, so the whole thing is raised to the 0 power. Anything raised to the 0 power is 1. How about this one? What's different? Well, what's different in this one is there's no brackets. You have to be careful. You have to think of bedmass. Remember bedmass? The first thing we do in bedmass is we look for brackets. There's no brackets here. The next thing we do is we look for exponent. Oh, there is an exponent. This little 0 is the exponent. So you have to do that first. The base of that exponent is not -8. The base of this exponent here is -8, right? This exponent, this 0 here, it's -8 raised to the 0 power. But in this one down here, it's not -8 raised to, it's 8 raised to the 0 power, and then you're going to slap the negative on after. So it's the same as this. -8 to the 0 power. So first you do 8 to the 0 power, which is 1, and then you slap that negative on. So this is actually -1. Okay, that's probably one of the most common mistakes in all of high school math, is that exact question there. Not necessarily with an 8, but with a 5 or a 2 or whatever, so be careful. Okay, next we're going to learn the product rule. Pretty sure you know this one too. So again, let's use an example to help us out. If I was multiplying 2 cubed times 2 to the 4th power, what does that equal? Well, 2 cubed is the same as 2 times 2 times 2, right? And 2 to the 4th power is the same as 2 times 2 times 2 times 2. So what do we actually have here? We have 2 times 2 times 2 times 2 times 2 times 2 times 2. Oh, that sounds like 2 to the 7th power. Now, how could we have gone straight from this first step up here? How could we have gone straight from here to here? What do you notice about the exponents? What you could have done is you could have just done 3 plus 4. This will always be the case as long as you have the same base. So a to the m power times a to the n power is equal to, the base stays the same, a, but now you add the exponents. Sound familiar? Pretty sure you did that before. So 17, gosh, I can't even read this. 17 to the 5th power plus 17 to the 12th power is equal to 17 to the 5 plus 12th power equals 17 to the 17th power. 5 6 to the 6th power times 5 6 to the 8th power. Well, what's the base? The base is 5 6, so that stays the same, 5 6. And now it's raised to the 6 plus 8 power. In other words, it's 5 6 to the 14th power. Do you need to have the fraction in brackets? Yes, you do. If you don't have the fraction in brackets, the 14 only applies to the 5, but we want it to apply to the whole fraction, so it should be in brackets. Now, this one looks like you can't do it. They don't have the same base, right? We said you need to have the same base, otherwise you can't use this product rule. But before we give up on this is horrible. I just really cannot read these numbers. That's a 5, and that is a 2. Before you give up on this, you actually can do this one. How can you possibly do this when they have different exponents? Well, what you have to realize is that 4 is actually a multiple of 2, right? So if we keep this as 2 to the 5th power times, now instead of writing 4 here, instead of writing the number 4, what could I write instead? I could write 2 to the what power? 2 squared. Right? Isn't 4 just the same as 2 squared? Yeah, 2 squared is 4. And what would still be left out here is another 2. Where's that 2 come from? That is this 2 right here. So that 2 is there, and the 4 is the same as 2 squared. See what I'm talking about here? Alright, now, in order to do the next step, we have to figure out what do I do with this? 2 squared squared. And we haven't learned that yet. Well, you probably did in previous years, but we're going to learn that in the next side of the page. So maybe I'll just leave this question. We'll come back to it in a second. By the way, there's something I forgot to say up here. There's one exception to this. Here I said that every number raised to the first power is itself, and here I said every number raised to the 0 power is 1. What happens then if you have 0 to the 0 power? Kind of seems like it should be 1, right? Because anything to the 0 power is 1. But something else you've learned, or you just can tell, is that 0 to any other power, like 0 to the 5th, what's that mean? That means 0 times 0 times 0 times 0 times 0, it's 0. What's 0 to the 4th power? 0 times 0 times 0 times 0, it's 0. 0 to the 3rd power is 0. 0 to the 2nd power is 0. It's always 0. So if that's the case, that 0 to any power is 0, but it's also the case that anything to the 0 power is 1, which one of those rules holds? Does this equal 0 or does this equal 1? Well, it turns out it doesn't equal either of them. It equals 11. No, I'm just joking. Not 11. 0 to the 0 power is undefined. It doesn't equal anything. Okay, so yeah, it's something that in math there's just no solution to it. We say it's undefined. Meaningless, kind of. Okay, so we're going to come back to this question. Sure hope I remember to do that. The quotient rule. The quotient rule is very similar to the product rule. Product means when you multiply two things, right? A product is when you multiply two things. A quotient is when you divide two things. So we need a rule for dividing. So again, let's go to our rule, figuring out our rule here. If we had 2 to the 6th divided by 2 to the 4th. Okay, well another way I could write that is 2 to the 6th over 2 to the 4th, right? And so 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. And 2 to the 4th is 2 times 2 times 2 times 2. And you're allowed to cancel things out when you multiply and divide, as long as you have one on top and one on the bottom. So those cancel. And these cancel. And these cancel. And these cancel. So what are you left with? You're left with 2 times 2, which is the same as 2 squared. Now, how could I, much quicker than what I just did, how could I go from this to this very quickly? Look at those exponents again. What I could have done is just taken the exponents and subtracted them. So our rule is that a to the m power divided by a to the n power is equal to a to the m minus n. Of course, that's also the case, the same if you have a to the m over a to the n, because that's what that line means there, right? It means divide. So it's a fraction, but remember that it means divide in a fraction. So this also equals a to the m minus n. It's just a different way of writing the same thing. Okay, so negative 9 to the 8th divided by negative 9 to the 4th. Well, our base is negative 9, and you do need to put it in brackets. And 8 take away 4. Don't have room. So negative 9 in brackets to the 4th power is your answer. Oh, this one, we have m to the 10th divided by m to the, what's the exponent here? 1, right? If there's no exponent, it's 1. So it's m to the 10 minus 1. We get m to the 9th. Great, let's move on. But we're going to come back to that question. I'm not going to forget. We're going to go back to that question right after this because this is the rule we need, the power rule. So, again, coming up with an example that'll help us figure this out. If we wanted to know what 2 squared cubed was, well, 2 squared cubed means 2 squared times 2 squared times 2 squared, right? Okay, now what does 2 squared equal? 2 squared equals 2 times 2. Times, what does 2 squared equal? 2 times 2. What does 2 squared equal? 2 times 2. So what are you left with? You're left with 2 times 2 times 2 times 2 times 2 times 2 times 2. Did I say too many? I can't remember. Anyway, that is 2 to the 6. All right, I ask you again, how could you quickly go from here to here without doing all this intermediate stuff, which wastes time? You could take the exponents, the 2 exponents here, and you could multiply them. So our rule is a to the m, any number raised to a power, which is then raised to another power. This is a power of a power. That's equal to a to the m times n. So if it's 12 to the 4th to the 7th power, it's 12 to the 4 times 7. We get 12 to the 28. If we have negative 4/5 as our base, have to put it in brackets, and then we have 8 to the 8th power to the 5th power. Well, we go 8 times 5, so we get negative 4 over 5 to the 40th power. Okay, let's move to the next one, raising a product to a power. Are you yelling at your computer screen right now saying, go back, go back? Yes, I remembered. Let's go back. So we're going to finish this one off now. So remember, what we did is we kept the 2 to the 5th the same, and we switched the 4 to 2 squared, because 2 squared is the same as 4, and we still have that highlighted 2 there as our other exponent. So look what this is. This whole thing here is a power of a power. So what we have, we still have the 2 to the 5th power, no problem, times 2 squared squared. Well, that's the same as 2 to the, what do we do with these 2 powers right here, these 2 exponents? You add them, 2 plus 2, that's the rule we just learned. So that's the same as 2 to the 5th times 2 to the 4th, because 2 times 2 is 4. And now we use the product rule. We have the same base, and what do we do with our exponents? We add them. So you end up with 2 to the 9th power there. By the way, you don't need to show me like every single step, like I'm doing every step here showing 2 plus 2 and 5 plus 4. I certainly don't expect you to do that kind of stuff. I'm just doing that. So I'm hoping that everyone can follow exactly how I'm getting these answers. Okay, back to the other page, raising a product to a power. So that would be something like 3m to the 4th power. Well, 3m to the 4th power means 3m times 3m times 3m times 3m. And 3m means 3 times m, right? So this is the same as 3 times m times 3 times m times 3 times m times 3 times m. And when you multiply stuff, you can do it in any order. So let's put the 3's together. 3 times 3 times 3 times 3 times, then put the m's together. M times m times m times m. Okay, this amount right here, 3 times 3 times 3 times 3, is the same as 3 to the 4th power. And this amount, m times m times m times, this is the same as m to the 4th power. We could, of course, figure out what 3 to the 4th power is, but let's just stop here. And again, I ask you, how do you go from here to here? Because this was way too much work to do all that. How could I go from here to here? And hopefully what you notice is what you could do is just realize that this 4 applies to the 3. You raise the 3 to the 4th power, and you also raise the m to the 4th power. There was once a teacher, which I can't believe you guys never knew because she's been gone more than a couple years now. Her name was Miss Jennifer Massoud, and she taught at our school. She was a wonderful human being. And she used to call this right here, what we just did here, she used to call this spreading the love. And in her honor and memory, that's what I have continued to call it, spreading the love. So the love, I guess, is the power or the exponent. It's the power of love. I love it. I just thought of that. That's the power of love right there. It's a power, right? And it's actually an exponent, but the whole thing's a power. It's the power of love, and you're spreading that love to all the things there. So the way that looks, I'll put that in quotations so you know that's not, believe it or not, what it's actually called in math. Other big shot mathematicians do not call this spreading the love. If you had something like AB, so A times B, and it's raised to the n power, that's the same as A to the n power times B to the n power. Okay, so 5m all squared. That's the same as, we're going to spread the love here. We're going to spread the love of 2 to the 5 and spread it to the m as well. So what we end up with is 5 squared and also m squared. Well, we know what 5 squared is. That's 5 times 5 is 25. M squared, we don't know what that is yet because we don't know what m is. So that's it, 25m squared. Next one, 2m squared n. You got to spread the love 3 times this time. This 4 here is going to be spread to the 2, the m squared, and also the n. So you end up with 2 to the 4th power, m squared to the 4th power. I'm going to put it in brackets so it doesn't look like m24, and n to the 4th power. Okay, 2 to the 4th power, that's 2 times 2 times 2 times 2, that's 16. M squared to the 4th power, how do I do that? That is this rule right up here, the power rule, a power of a power. So that's equal to, what do I do with these exponents? I multiply them, 2 times 4, and then n to the 4th power. So my final answer is 16, m to the 2 times 4 is 8, n to the 4th power. Finished. All right, last one in this section. We have negative 2 c d to the 8th all to the 3rd power. You got to spread that love to the d to the 8th to the c. Now, you can think of this in two ways. You can either think of this spreading the love to the whole negative 2, or you could think of it as spreading the love to the 2 and also to the negative. I think thinking of it as the negative 2 is a little bit easier. If you did think of spreading it to the negative, you'd have negative to the 3rd power. In other words, it's like 3 negatives. Do 3 negatives make a positive or a negative? Makes a negative. But if that doesn't work for you, and the way that I think most of us will probably do this, is you think of this as being negative 2, got to put it in brackets, negative 2 to the 3rd power, c to the 3rd power, and d to the 8th to the 3rd power. Okay, negative 2 to the 3rd power, that's negative 2 times negative 2 times negative 2, which is negative 8. Basically, as long as your exponent here that you're spreading the love of, as long as it's an odd number, a negative will remain. It'll still be negative. If it's an even number, the negative is going to disappear. I think we have one down below where it disappears. I really don't like that equal sign, so I'm getting rid of it. Okay, so this is equals negative 8. We did negative 2 to the 3rd power. C to the 3rd power is nothing we can do there. And d to the 8th to the 3rd power. Oh, there's the power rule again. So what do we do with the 8 and the 3? We multiply them, 8 times 3. Final answer, negative 8 c cubed d to the 24th. Okay, raising a fraction or a quotient to a power. So this would be something like m over 3, which you could think of as a fraction, m over 3, or m divided by 3, it's the same thing, right, to the 4th power. Well, that's the same as m over 3 times m over 3 times m over 3 times m over 3, isn't it? And when you multiply those things together, in the numerator you'd get m times m times m times m, and the denominator you'd get 3 times 3 times 3 times 3. Now what's that equal? M times m times m times m is m to the 4th power. 3 times 3 times 3 times 3 is 3 to the 4th power. We could expand the 3 to the 4th, or figure out what that equals, but let's not, and answer the question, what could you do to go from here to here? Guess what you could do again? You could spread the love again. Basically what you could do is this spreads there and there, so you end up with m to the 4th, 3 to the 4th, just like we got there. How do we write that? We say that a over b, a divided by b to the n power is equal to a to the n power over b to the n power. Okay, let's do it. First one here, we got to spread the love to the f and the 8, and it's a 2, so we get f squared on the top, 8 squared on the bottom. Well, we know what 8 squared is. It's 64, so we can write that. Next one, we've got to spread the love 3 times. This 3 is going to spread to the 1, the 5, and the n cubed. So we get 1 to the 3rd power over 5 to the 3rd power, and then we need an n cubed to the 3rd power. What's 1 cubed? That's 1 times 1 times 1, which is 1. What's 5 cubed? 5 times 5 is 25, times another 5 is 125. And now we have a power of a power. Can we now just stop writing exactly how I do this every time? What do I do with the exponents? I multiply them, right? So this would be n to the ninth. 3 times 3 is 9. I'm just not going to write that step like here where I put 8 times 3. I'm not going to write 3 times 3. I'm hoping we figured that out by now. Okay, last one. We have all sorts of spreading the love here. You got to spread the love to the a, to the 3, to the negative if you want, or you could think of it as negative 3, but the negative's way out here, so you might want to think of spreading the love to the negative. You got to spread the love to the n, to the m5th, and to the 4. My goodness, that's a lot of love spreading. So what we have is, first of all, this negative here, it's kind of like negative 1. So you could put negative 1 squared. Or the other way, and I think most people will do it this way, you think, okay, well this negative, I got to put it somewhere. I'll just slap it onto the 3 here. So negative 3 squared. Then we have a squared. On the bottom we have 4 squared. Then we have m to the 5th, all squared. And then we have n squared. Negative 3 squared, that's negative 3 times negative 3, which equals 9. Remember, this is that case I told you. If the exponent up here is even, your negative will disappear. If your exponent was odd, like this one up here, the negative sticks around. An even number of negatives turns it into a positive. Okay, so we've done the negative 3 squared, and then we have a squared. On the bottom we have 4 squared, which is 16. We have m to the 5th power to the 2nd power. So this is another power of a power. What do you do with those exponents? Multiply, so you get m to the 10th power. And then we have n squared. And that's our final answer. We're done. Okay, I just want to caution you of one other thing. This spreading the love, there's some cases where people try it where it doesn't work. A plus 2 to the 3rd power. A lot of people think, oh, I'm going to spread the love here, and so this equals a to the 3rd power plus 2 to the 3rd power. That's not true. No. Also, something like 5 minus m squared does not equal 5 squared minus m squared. No. So basically what I'm trying to show you here is you cannot spread the love with subtraction and addition. See how this is an addition question? This is a subtraction question. You cannot spread the love with those. You can only spread them with division or multiplication, with subtraction or addition. Okay, and once I've written that, I'm done. So good luck with today's work, and learn it well, and prepare yourself, because next class is probably one of the hardest of the whole course. I hope you're looking forward to it.
And then one day you find 10 years have gone behind you. No one told you when to run. You missed the start.